This class we are going to discuss about the nuclear chemistry. Nuclear chemistry is a branch of chemistry dealing with radioactivity, nuclear process and the nuclear properties. So we will discuss about some radiochemistry aspects, nuclear power, nuclear reactions and its applications. Listen the point. The radiochemistry is nothing but a study about the chemistry behind the emission of radiation. Not like chemistry, it is also physics behind the emission of radiation. The emission of subatomic particles are high energy electromagnetic radiation by nuclei. Such atoms or isotopes are said to be radioactive. So it is a spontaneous phenomenon. It is called such radio emitting, that is called such radiation emitting nucleus is called radionuclides. It is called as a radionuclides. So here, before entering the subject, we should know what is isotope. Isotope is nothing but any two element which differ only in their masses but possess the same atomic number. You know what is a atomic number? Atomic number is nothing but a number of protons present in the nucleus. Sometimes it is also called as a number of electrons, because for any element is nothing but a neutral, so number of protons is also equal to number of electrons. So it's nothing but the isotopes means it represents any element which possesses the same atomic number but different mass number. That is a mass number may be different. Okay, discovery of radioactivity. It is discovered radioactivity discovered in 1896 by Henry Becquerel. The first radioactivity phenomena observed in 1896. Marie Curie and Hubby discovered two new elements, both of which emitted in ironic rays. Polonium and radium, the first radioactivity element discovered by Marie Curie and Hubby. I think both are husband and wife. So polonium, the first radioactive is called polonium and radium. The Rutherford and Curie found that emission produced by the nucleus is called. There are why such what they studied what are the types of emission. They observe radioactivity means it emits some radiation. What is the nature of the radiation? Started to research. One is called they classify according to the emission: alpha decay, beta decay, gamma ray emissions. Means emission of alpha particles, emission of beta particles, and emission of gamma particles. So these emitted particles quite different from each other in the different aspects. So first called alpha decay. Let us talk about alpha decay. It's the largest ionizing power. Ability to ionize the molecules and atom due to the largeness of the alpha is nothing but a helium nucleus. If we just consider the helium element without the electron, so only contains only nucleus, helium atom without electron. If it contains only nucleus, called alpha particles. It has the lowest penetrating power. Ability to penetrate the matter, skin, even air, protect against alpha particles radiation. So alpha particles ionizing power is large, but the lifetime is very low. So able to ionize molecules of air when it passes through the atmosphere. It also low penetrating power is very low, but ionizing power is very high. So it may penetrate only skin in air only, but couldn't penetrate very massive, very rough matter. Beta decay. It possesses a lower ionizing power than alpha particles, but higher penetration power. The ionizing power, penetration power, it possesses an inverse relationship. Means ionizing power means able to ionize. How much able to ionize the given molecules? It's called low. Beta but possesses a low ionizing power, but penetration power is little bit higher than your alpha particles. It requires a sheet of metal or thick piece of wood to arrest the penetration. So to just because of the high penetration power, it's a little bit higher penetration power than alpha particles. It needs little bit thick sheet of metals or a piece of wood we need to just stop the penetration, to just prevent the beta particles. More damage outside the body, but less. So outside the body possesses damage, but when compared to the alpha particles, it's somewhat higher, produces somewhat higher damage. Electromagnetic radiation. Here the third one is called gamma ray emission. The alpha and beta particles are nothing but particles. It's only particles. But the third is called gamma ray. It's nothing but electromagnetic radiation. But alpha and beta particles is nothing but only particles. It doesn't comes under the electromagnetic radiation. The third is called gamma ray. This is also emitted from the radioactive nuclei. So this gamma ray, this gamma ray is nothing comes under electromagnetic radiation. It's nothing but high energy photons. But the alpha and beta particles are not high energy photons. This is only gamma ray. It's nothing but electromagnetic radiation. It is high energetic radiation, so no doubt at all. Immediate next to the cosmic ray, we are having gamma ray electromagnetic spectrum, somewhat highly energetic, no charge, no mass. But helium particles, beta particles possess the charge and mass. Helium particle possess the charge as well as a mass. The beta particle possess only charge, not a mass. But the gamma radiations, just like your photons, it's nothing but doesn't possess the no charge and no rest mass. Usually emitted in conjunction with the other radiation types. Low energy power, high penetration power. So penetration power is very large when compared to the alpha and beta particles. It requires several inches of lead shielding. Due to the lead shielding, by lead shielding only we can stop the emission of the gamma radiation. So just like they are comparing, I think comparing like this penetration power. Here this is a very subject point. It is a very important subject point. It is a very important. It's called alpha decay. Here is called alpha decay. So due to the alpha decay, so what happens? The alpha particles started to emit. So this is called parent nuclei. This is called parent nuclei. This is called parent reactant. Is called parent nuclei. This is called daughter nuclei. So due to the expulsion of the alpha particles, here A represent the mass number, Z represent the atomic number, N represent the how many neutrons are emitted during this one. So due to this emission of alpha particles, your atomic number, this is your mass number, A represent the mass number, another A represent the mass number, which is decreased by 4 units. Your atomic number is decreased by 2. Atomic number is decreased by 2. So means what? There are 2 neutrons are emitted. The emission of neutrons is 2 neutrons. So it's called beta decay. So this is called daughter nucleus. This is parent nucleus. Upon expulsion, it started to emit beta particles. Due to this emission of beta particles, mass number doesn't changes, but atomic number is increased by 1 as of the, but while simultaneously neutrons are started to emit. The positron emissions, due to these positron emissions, another one emission is also here pointed out. Due to the high energy photons we started to capture in the particular nucleus, what happens is daughter nuclei converted to parent nuclei. The positron also simultaneously emits the particles. So due to this one, this atomic mass number doesn't changes, but atomic numbers decreased by 1 unit due to the expulsion of the neutrons. Electron capture is called electron capture. So just when the X-rays is absorbed from the low energy, when X-rays are absorbed into the lower energy into the nucleus. So where is X-rays? It's nothing but a X-ray photon. Which is emitted from the low energy orbital of the same element and absorbed by the nucleus, automatically converted into parent nucleus. Here the atomic number, so here the mass number is doesn't changes, but atomic number is decreased by 1 unit. So this is called due to the electron capture. This is called the K-shell electron capture. This is called gamma emission. So in the gamma emissions, the excited nucleus is converted into another parent nucleus, excited nucleus converted into daughter nucleus with the liberation of the gamma photons. With emission of the gamma photon, there is no change in mass number, atomic number, and there is no particles are emitted. So listen the point. So upon it is called something but a group displacement law. We can make it a group displacement law. Due to the alpha emission, the atomic number is decreased by 2. Due to the beta emission, the atomic number is of the element is increased by 1. Here all are nuclear event. There is a no bond breaking, not like a chemical reactions. All of it all happens within the nucleus only. So due to the beta emission, atomic number is increased by 1. Due to the positron emission, atomic number is decreased by 1. And due to electron capture, so atomic number is also decreased by 1. So just like your positron emission, so the main difference is here, when a high energy photons also here also captured, so sometimes it leads to the positron emissions. Here also the same X-ray photons when started to absorb due to the relocation, there's a release of the photons from the cation of the outer cation of the electronic configurations. So it is absorbed by the nucleus itself, gives sometimes electron undergoes electron capture. So so atomic number is it decreases by 1 unit. The positron emissions, electron capture seems to be both are equal. The difference is only here. The difference is only here. Is any high energy photons, but here is X-ray photons. This is called what? X-ray. This is called X-ray photons only. So see, gamma emission, nothing happens. There is no changes in mass number, atomic number, or there is some nothing, no particles are emitted. Here the beta particles are represented as beta, mass number 0, atomic number -1, positron emission. Just like the mirror image of this one, the mass number is also 0. Here for beta -1 means positron emission +1. So this is what is happens here. This is called what? X-ray photon. Nothing happens here. Electron capture. Here is a gamma ray. Doesn't possess any kind of charges and mass. So it seems to be like this. So this is called. So keep it upon emission of the alpha. Mind keep it in mind. Upon emission of the alpha decay, atomic number is decreased by 2. Mass number is decreased by 4. Upon emission of the beta particles, atomic number is again increased by 1. There is no change in the mass number. Upon emission of the positron emission, atomic number is decreased by 1. There is no change in the mass number. So these are the very important. Upon emission of the gamma emission, atomic, there is no change in the mass number and atomic number. So this is schematically represented very clearly. So keep it in mind. But in the case of electron capture, again the same things are here. X-ray photons. Here electron capture, there is no change in no change in so only this is called what your this 0 -1 means is a positron emissions. Radioactive series. So normally the radioactivities occurs naturally. So initially from in the higher atomic number. So if a element is biodegradable, like uranium, it possesses the highest mass number. It possesses the highest mass number.